Let us now solve the questions like this cubical arrangement. You can see this is the cubical arrangement, and the statement is a battery of 10 volt and negligible internal resistance is connected across the diagonally opposite corners of cubical network. Diagonally opposite means this terminal A and this terminal N, right? So a battery is connected across these diagonally opposite. This value is 10 volt and consisting of 12 resistors, each of resistance 1 ohm. 1 ohm resistance is given to you. Determine equivalent resistance of network. We have to find out this equivalent resistance of this network and current through the battery. Now to solve such complicated circuit, here the condition, what is the condition here is, condition is the circuit E battery is connected across the diagonally opposite. It means if we are talking about this loop A, let us name this A, B, C, D, and this is L, K, M. So it means if we talk about A, L, K, N and A, this loop, and A, L, K, N, L, C, B, this upper loop, these are connected in parallel. So it means the EMF across this lower loop and this upper loop should be equal. So if we can get this relation, we can easily find out the equivalent resistance by equating both the EMF. Let us find out. To start with, let us consider the battery, this battery. मान लीजिए we have considered here that this battery is giving the current, suppose 6I for convenient, right? Now this 6I will be divided into 3 parts. Let this is 2I in this part, 2I in this part and 2I in this part. So total is 6I. Now at the end it should flow or go outward. Current should be also 6I. So now this 2I current at this point will be divided into I and I. Similarly, this 2I current at this point should be divided into I and I equal currents. And similarly, this 2I at B point should be divided into 2 parts, I and I. Right? Now coming to this point, this junction K. Now this current I and this current I when meet gives the resultant current 2I. Means that in this arm the current 2I is flowing and entering at point N. Similarly, at this junction, if we talk about this current I and this current I meet at this point and gives the resultant 2I. It means 2I is entering at this junction. And similarly, if we talk about this arm, at this junction C, current I and current I join together and gives the current 2I. So total is 6I current will leave this junction. Now let us apply Kirchhoff's second rule to the loop A, L, K, N, A. A, L, K, N, A. Right. Now since we have considered here the equal resistance equal to 1 ohm here, value is given to you. Let us consider the resistance is equal to small r is equal to 1. Since it is internal resistance, so we represent it by small r. So in the arm AL, we are traversing in this direction and the direction of current is also in this direction. So that is taken to be positive 2I into R. Just to specify R, we can put the value 1 also just to clear the confusion. That is why we have put here value R. When we move across this path, this becomes I into R. Why positive? Because we are traveling in the direction of current. Again, in this direction KN, 2I into R. 2I into R is equal to EMF. EMF is taken to be positive because we are looping the loop and negative terminal encountered first. So that becomes 5I into R is equal to EMF. Now suppose capital R is the resistance of this whole combination. In that case total current is 6I. So 6I into R is equal to EMF of the circuit. So comparing these two, we get 5I into R is equal to 6I into capital R. Or we can say capital R is equal to 5 by 6 into small r. Since the value of R is equal to 1, so we can write here 5 by 6. Similarly, since we have calculated the resistance, we can calculate the current. I is equal to total voltage upon the resistance of the circuit external. So putting this value 10 upon 5 by 6, so this becomes 60. 5 2s are 10, 6 2s are 12 amperes. So this is done.